Hi guys, sometimes I won't have time to meet with each individual student about their lab work, and when that happens, I'll often do what I'm about to do right now, which is show you a lab from a student that I had several years ago, and show you some of the common errors that students make by using this lab, and hopefully that'll help you see the mistakes that you made in your own lab. If that doesn't work for you, that's okay. You can come see me individually about your lab if you still have questions after you've watched this. So the first thing that I'm noticing is on this page, the student's hypothesis kind of doesn't make sense. The student is hypothesizing that there's a strainer in the box, and there's a couple of problems with that. One is this hypothesis was supposed to have been made before you did any experimenting, so that makes me wonder where they got that idea from. So I go and I look at the rationale, which is supposed to explain to me where the idea comes from, and it says because of the sand. Now, I could probably fill in some blanks here and assume that what the student is trying to tell me is that when they put sand in the box, it seemed not to go through, and that this made them think that there was a strainer. But I have to assume that because that's not what the student is saying. Maybe I could assume something else. Maybe this student is saying just the fact that I had sand sitting on the table before they did any experimenting with it, maybe that made the student think that there was going to be a strainer. It's hard to believe that that's the case, but maybe that's what the student meant. I really can't tell. So what I would have liked to have seen would have been something that first of all, was done before any experimenting. Even the drawing here kind of makes me feel like they've done some experimenting before they've done any hypothesizing. Because look, inside the box it looks like they have the tube splitting into two parts, and there's just no explanation of that at all. And in fact, the hypothesis doesn't mention what's in the drawing, which is a tube that comes straight down and then branches. So there's a lot of unexplained stuff on this page. So look at your own hypothesis and rationale and ask yourself these questions. First of all, did you hypothesize before you experimented? If not, you want to try and go back and find the state of mind you had at the very beginning before you knew anything about the box. What did you think of the inside would look like back then? See if you can recreate that for yourself. And then after you write down what you thought, go back and see if you can explain what made you think that. What was the hint or clue that made you decide that that should be the case? A lot of students will tell me that they think there's going to be 3 tubes in the box as their hypothesis, and their rationale is just, well, you told us there were 3 positions for the funnel. That made me think that the box must be divided into 3 different parts. And that would make sense. Okay, let's look at this student's procedures, data, and hypothesis page. It's a little bit blurry, but I think you can kind of see what this student has done. So on the left-hand side, they wrote down that they put 40 milliliters of water. I think it's fine to use shorthand and just say, put 40 milliliters of water instead of writing a whole sentence. But the problem here is that they haven't told me where they put this 40 milliliters of water. The funnel has 3 positions, and they haven't told me what position the funnel's in. And so that means that when they write down what happened, I don't really know what exactly this means. They said that red came out and it smells like Kool-Aid, which are good observations to write in there, but also missing an amount. How much came out? How much red? Approximately 40 milliliters come out, or did you get less or more than you started with? That's important to know because that'll help you understand how the box works. So there's not enough detail here. The hypothesis on the right, I didn't really grade these, but I do notice that the student has shown a tube with a circle in the middle that says red Kool-Aid, and that's okay for sort of notes to yourself. But if you really think about it, I'm not really sure what they mean by red Kool-Aid. Do they mean liquid? Do they mean powder? How is it in there? If it's a liquid, why isn't it falling through? A lot of unanswered questions in that drawing. But again, I didn't grade the drawings in your hypothesis section. Those were more for you. The second box says put 1 salt piece. Piece is spelled incorrectly, but that's not a big deal. I don't take off points for that kind of thing. So it's good that they said they put 1 piece of salt, but again, not telling me what position the funnel's in doesn't help me. And then instead of writing nothing, I think they should have written nothing comes out, but I get what they mean by the word nothing. I find it interesting that the hypothesis stayed the same though. Isn't this new information that shows that, well, water comes out, but salt doesn't? So shouldn't there be some kind of new explanation about what's going on inside the box? Then it seems like the students started to get the hang of it. Okay, put 10 milliliters of water. Again, not telling me what position the funnel's in. They start to do that here, right? We're in the right side, we're in the middle. So it's kind of like as they went along, the student got better at this, and that was very common with your lab sheets. I thought this was interesting. They said that when they put 10 milliliters of water in, I'm not sure what side they're on, but I think it might have been the left side, because they said more red than purple. Again, this is shorthand, and it's not a problem. I know that they mean more red water came out than purple water came out. But because there's no amounts here, I'm not sure if it's an equal amount of red followed by an equal amount of purple, or if it was just sort of dripping red and then purple came out about 10 milliliters. It's really not clear. And it's also not clear why the hypothesis hasn't changed. They wait till they get down here to show that they think that there's now 3 different sections. And then they did the same thing with put sand. They didn't really tell us where they put the sand. Maybe it was all 3. So look at your own procedures page and ask yourself, did you write down the amounts and the location of the funnel? And when you wrote down what happened, did you really explain what you saw? If you want to redo this page in order to improve your lab, if you look closely at the black box lab sheet fixes sheet, you'll notice that I said if you're going to redo your procedures, that instead of rewriting the procedures you've got, you should rewrite them as if you were going to do it again. And I think this is more useful than just going back and fixing your old procedures, because you probably don't remember the amounts and the locations and all that stuff. So instead, what I'd like you to do, if you're going to redo this page, is to write down just sort of a bulleted list of the procedures you would run if you were going to redo the whole lab, with enough detail that you would get all the observations that you're supposed to get. And I think that that's a more useful way to redo your procedure section. And if you do that, you don't need to do the data and the updated hypothesis, because that part you haven't actually done. You're just making sort of a plan for what you would do. All right, let's take a look at the conclusions. Okay, so this is the student's final sketch. This is a very typical final sketch for when you're doing an individual sketch. There's a couple of problems with it. If you look on your rubric, you'll see that one of the things you're being graded on here is that the drawing is neat and clear and easy to interpret and understand. And I think it's that. I do mostly understand what's going on here. I have a few questions, but they're not major. But I'm having a hard time seeing how this explains all the observations. For one thing, what's going on with the funnel? How does it direct the flow of water? I can't tell. This is one of those things that students often don't figure out until after they work with their group and they go around and sort of nag everybody about it. So you probably do have an idea now, but maybe you didn't when you first drew your drawing. The other thing is, as I mentioned before, they're telling me that there's Kool-Aid powder in these 2 circles, but they're not telling me what form it's in. I'm assuming it's powder, but maybe they mean liquid, and I don't know. So if you said that that was, red and purple, or red and blue, and you didn't identify what exactly was red and what exactly was blue, you need to go back and do that. And if your substance is defying gravity, you need to rethink how it's staying up there, right? So if this is a liquid, or even if it's a powder, it doesn't make a lot of sense because gravity should just be pulling it down. Something would need to be holding it up and yet simultaneously allowing water to come through. The filter is okay. I don't mind that this is just a line showing a filter. It could have been more detailed. If I was drawing it, I probably would have done, I would have used a perspective drawing to make a filter in there, but that's because I'm fancy like that. I would have done something like that, but that's okay. I don't have a problem with that. I do think that it's weird that they have this branching here, since the box doesn't have that, right? That there may be 2 tubes that come together into one, but that must happen before we exit the box. So that doesn't make a lot of sense. So I would say that the person's going to lose a lot of points here because their drawing just doesn't explain all the observations. How does the funnel direct the flow of water? How does that Kool-Aid stay up against gravity? And so on. But otherwise, it's pretty good. Let's look at the actual conclusion questions. Actually, before we do that, I just remembered. The other thing that you might have lost points for on this page, aside from not explaining all of your observations, would be if you didn't apply Occam's razor. So Occam's razor says you can't make any assumptions that there's no reason to make. So one of the places where people make extra assumptions in here is where they'll sort of add like extra filters and things that they don't need, or overly complex ways for water to get in and out of the sections where they have the coloring happen. So just check to make sure that you haven't added anything that isn't unnecessary, and to make sure that you're applying Occam's razor. Okay, now the conclusion questions. Okay, so here is where I really should get to see your thinking. And it's hard, I find, for students to answer questions like this because of two reasons. One is that you've sort of been trained by other teachers that you need to rewrite the question. So sometimes students find with these tiny little amounts of space that I'm giving them, after they rewrite the question, there's no more room left for their answer. I don't expect you to rewrite the question. You can jump right in with your answer. That's one thing that this student, I think, was pretty good at, and you'll see that in a second. The other problem that students have here is it's hard to explain how you know what you know or what you're thinking, right? We make a lot of decisions in our mind that we don't even know how we did that. So what I'm really asking you to do on this page is go back and sort of peel back the curtain and look inside your own brain and figure out how you decided these things. And that's not easy to do. It takes a lot of thought. And that's why students often struggle with this part. So if you look under the conclusion questions, this student, the first question says, describe how your drawing explains your observations. The student does a pretty good job here. The student said, I saw nothing comes out the middle, so it isn't attached. Now, they could have been a little more detailed if they had a little more room, but I know exactly what they mean here. This student is telling me, listen, I made an observation. Nothing came out the middle. I drew a conclusion. The middle's not attached to the exit tube. You see that? That's what I'm looking for here. When I say, how does your drawing explain your observations, I expected you to name an observation and then name something in your drawing that explains it. So the student does it again. They said the red and purple is from Kool-Aid. It's, again, not a lot of explanation, but I do get the idea from what the student wrote here that they understand that they observed two different colors coming out, and they're attempting to explain that with Kool-Aid being on two sides of the box. And the strainer explains why the sand and the salt don't come out. So you see that if most students didn't do well in this section, it was probably because they said, well, my drawing explains my observations because it shows how the box works. Well, how? Right? So you see those details are often missing because students just say, well, it's obvious. The picture explains it. That's why I drew the picture. And what I wanted you to do was to use words to do what your picture did. And that's what this student tried to do here. So I would say that that's a pretty good answer on the top. Could be more detailed, but it's fine. The second question is where the student sort of doesn't really give me enough detail. The student's giving themselves a 9 on how confident they are about their drawing. And their reason for that is, I'm sure it's Kool-Aid because, and please don't do this, you should write out the word because. We're not texting, guys. Because I can smell it, but I'm not sure about other things. Okay, so there's one detail here. The detail about the Kool-Aid. The student's telling me, hey, I'm pretty sure there's Kool-Aid in there. I know the smell of Kool-Aid. All right, I don't know that. I think that's an assumption the student's making. Lots of things smell like Kool-Aid. Kool-Aid itself smells like fruit, right? Whatever fruit flavoring it happens to be. And lots of things can be made to smell like that. So I don't know if this student should be as confident as they are just because of that. The other problem, though, is then they just get all vague. After they say they can smell it, they say, I'm just not sure about other things. That's why I didn't give myself a 10. You have to be way more specific than that. Let's say you gave yourself a 9. Well, then I would expect you to say, I'm giving myself a 9 because I'm pretty sure a strainer is the only way to keep sand and salt out. I'm pretty sure that the substance inside the box is Kool-Aid based on the smell. And I'm also pretty sure that there has to be something stopping up the middle to keep stuff from coming out. The reason I haven't given myself a 10, however, instead of a 9, is because I know that there's more than one way that each of these things could work. Maybe instead of a strainer, there's some other device I haven't thought of. Or maybe instead of Kool-Aid, there's some other substance that smells like Kool-Aid that's in there, and so on. Those kinds of details have to be brought up here, and they're just not. So the student would lose a lot of points there. Same thing with the bottom. I asked the student if their hypothesis changed over time, and if so, what made him change it, or her, as the case may be. And the student said yes, again, texting the word because. Yes, the hypothesis changed because we kept making new discoveries each time we added something. Well, I sort of knew that. That's obvious. That's why your hypothesis changes. The question is, what were these new discoveries? So I was expecting the student to say things like, at first, we thought that there was only one tube going from the top to the bottom. But then when we started experimenting, we realized there had to be two because we got two different colors. And then when we put sand and salt in, we realized that they didn't come out, so there had to be something blocking that. So we hypothesized that there was a strainer. So details are how you explain your thinking. And it's hard. I understand that it's difficult. But if this is where you fell down, you should go back and try and figure out, well, what are the details that back up what I'm saying? And if you do that, I will be able to regrade your lab. So when you're done fixing anything on your lab, make sure that you write on the top of it, please regrade, and then you can submit it to me in the front of the room, and I'll put it in my folder, and I will regrade it as soon as I can. If you still need to talk to me about your lab, that's totally fine. I don't mind meeting with you. I just know that doing it this way, some students at least will be able to redo their lab without talking to me individually, and that'll make me have more time for people who need more of a one-on-one. So I'll see you guys in class.